Welcome students to the lecture 4 on the chapter wave optics. In the last lecture, that is lecture 3, we discussed the reflection phenomenon using wave theory or Huygens principle, refraction phenomenon using wave theory or Huygens principle, and we also discussed the concept of Doppler's effect in case of light. In this lecture, we are going to understand the phenomenon of interference. We'll move further to understand the experimental setup created by Thomas Young, which is called Young's double slit experiment. Now here if you see this person, he have two balls using which he is creating the waves on the surface of the water. Now, two balls which are being vibrated similarly. So therefore, whatever the waves that we get on the surface is due to the combination of disturbance produced by the two sources. So therefore, it is not as simple as in case of one source. We understand the two disturbances, they combine to produce the resultant one. Now this resultant ripple produced on the surface of the water looks something like this. If you see, you find that there are some region where the disturbance doesn't exist. So between two huge disturbances, there is a position where the disturbance is zero. The surface of the water appears flat. So this phenomenon is interference of the waves due to two disturbances produced on the surface of the water. And we can call the pattern that we get on the surface of the water as interference pattern of water ripples. Now, similarly, in case of light, what we find is, if we have plane waves incident on two slits or two pinholes, the wavefronts from the slits or the pinholes further will combine to produce alternating bright and dark fringes. If you see here, this is the interference pattern of light, and if you compare, it is very same as we got that on the surface of water. Now what happens if I remove the slit? If I remove the slit, then the plane wavefront falls on the screen and everything will be uniformly intense. Each and every part on the screen will be uniformly intense. But when I keep the two slits, then rather than getting uniformly intense, the light energy gets redistributed. There will be certain region where the amount of light that falls will increase, whereas there will be certain region where the amount of light that falls will decrease, and sometimes it can minimize to zero. So the amount of energy that falls on the surface is same. The only thing is it has been redistributed. The light energy have been taken from one region and it has been added to some other regions. Now why this happens? Why this happens? This happens because of the phenomenon called interference. So it is defined as the phenomenon of redistribution of light energy in the medium on account of superposition of light waves from two coherent sources. It is a phenomenon of redistribution of light energy in the medium on account of superposition of light waves from two coherent sources. So this phenomenon is called interference of light waves. I would again stress, in interference, the light falling on the screen will be same in presence of slit or in absence of slit. If we keep the slits, two slits, then the distribution of light energy will be such that the modification leads to the removal of light from some region and the same amount of light is added to some other regions. Now, what do we mean by coherent sources? Let us take with a rough idea. So, I have two comparisons. So, one is called incoherent, which is not coherent. Now, what does that mean? So, here I have some 5 waves of different colors, which means that they are of different wavelengths and they are incoherent. The waves are not coherent, they are not same. In second diagram, all the waves are same. So, therefore, all the waves that we have in the second region, second diagram, are said to be coherent. In other words, here I have light coming from two sources. The wavelength of the light is same from both the source, but the phase at an instant is not same. But the phase difference between any two positions at certain distance is same. So therefore, phase difference is same, but phase is not same. In the earlier diagram, even the phases were same. So therefore, we define coherent sources as something like this. So coherent sources of light are those sources which emit a light wave having the same frequency, wavelength and in same phase, or they have constant phase difference. A coherent sources forms sustained patterns when superimposition of waves occur and the positions of maxima and minima are fixed. So coherent sources are those sources which emit the light which have the waves of same frequency, wavelength. The two waves should be either in phase or they should have constant phase difference. Now here we have the diagram for Young's double slit experiment. The light from the source is given out which passes through the slits, and after passing through the slits it produces alternate bright and dark fringes. At the center we get a bright band, and then on either side we get a dark then bright, then dark then bright. So this is the construction of Young's double slit experiment. As per the text view is concerned, we have it something like this. We have a source of light, then we have a single slit, and then we have two double slits. The light from two slits emerge out. So the double slit makes us to feel that there are two slits, and the light from these two slits falls on the screen to produce the interference pattern. A question arises, why double slit? Why can't we use two sources? Now practically, two isolated sources or two separate sources cannot act as coherent source due to many reasons. So therefore, the better idea is to have two sources out of single one. So therefore, we go with this kind of setup. So this experimental setup is called Young's double slit experiment, which again consists of a single source from where the waves moves and it is incident on the double slit. Double slit acts as two coherent source, and the light from the two slits undergo interference to produce the alternative bright and dark bands on the screen, and this pattern is called interference pattern. Thank you.